you're here, it's really important that you're present, and it's also important that you're paying attention. I'm going to record this because I want to give some reminders, and I feel like this class I have to give a lot of reminders, and that's okay. First things first, Canvas. Everything that you need to know about this class, the important stuff, is in Canvas. So if I go to Canvas, I'm not sure if this is, oh, that's the wrong class, my calculus class. Let's go to geometry class. You know, my email, my phone number, you know, you already got all that stuff. But let's get down to this week. And this week, I think, is the February 8th week. So this is, we are now all the way into week 6. So this week, you can see that our lesson is section 7.4. You will see some more stuff. Oh, there's the homework assignment that you need to be working on for tomorrow night before 9 o'clock. Oh, what else is going to happen this week? You guys have a quiz tomorrow. In fact, if you look back at last week's module, I had posted a review for that quiz, and the answers are now available too. And I mentioned to you last week that we would be having a quiz this week. So again, I just want to point out how important it is for you guys to be keeping tabs on what's going on in Canvas. If you ever aren't sure what's going on, go to Canvas. Number 2, homework. Some of you guys are doing a great job of getting your homework done, and that's awesome. I appreciate it. I feel, and this is my opinion, I feel giving you guys one homework assignment a week is very reasonable. Very reasonable. If you think about when you've taken math classes in the past, your teacher probably gives you 3 or maybe 4 homework assignments a week. You're only getting one homework assignment a week, and you have over a week to do it. That homework assignment was unlocked last Friday, and it's due this Friday, so that's a whole week. Now, the reason I'm bringing up homework specifically today is if you have missing homework, you, for whatever reason, I don't care what the reason is, you haven't done an assignment, you've forgotten to do something, you weren't feeling well, whatever the reason, if you have missed the homework from, let's say, 2 weeks ago, you can still make up that homework. But guess what you have to do? You have to send me an email and say, hey, Mr. Allen, sorry, man, I forgot to do, you know, whatever, section 6.6 homework or whatever it was. Because now when you try to access that homework, it's going to say, what's the password? Now, the reason that I'm doing that isn't to be a jerk. It's because last semester, students would make up homework, and guess who they forget to tell? Me. And then they'd be like, Mr. Allen, I understand why you have a 0 in Skyward. I did that homework assignment, but it says that I still got a 0. And I'm like, well, because you never told me you did the homework. Every week on the weekend, I check all the homework for all the students, and I grade it. Therefore, from now on, if you have missed a homework, you need to send me an email and say, hey, Mr. Allen, can I go make up that homework? And I'll be glad to let you make it up. Now, you're going to lose 10% of the grade, but you can make it up, but I got to give you the password. That forces you to engage me. Look, you're the one, if you didn't do the assignment, you're the one that kind of dropped the ball in the homework. So you're the one that has to kind of pick up the ball and let me know that you want to make up the homework. And by the way, I'm not going to be mad at you. I'm not mad at you at all. In fact, I'm excited that you want to make up the homework. I just want to make sure I put a grade in for you. Quiz, I already mentioned that. We have a quiz tomorrow. So please be aware there is a quiz tomorrow. That means you need to be here at 7:10 on the dot. We'll take the quiz. And then that'll be that. And then last but not least, I want to talk about help. And I want to talk to anyone in this class right now that's listening to me that has a grade of D or lower. If you have a grade of D or lower, my question is this. Have you responded to my messages? Have you come to my advisory? Have you reached out to me? I've tried reaching out to you, and I've also tried reaching out to your parents, and maybe I'm not getting any kind of communication, nothing. Guys, you got to help me out here. I can't give you points for stuff you don't do. And when I'm reaching out to you saying, hey, you need to make up this quiz, or you've got these assignments missing, you need to get with me so we can get you caught up. If you're struggling with the class and you're like, Mr. Allen, this class is just too hard, please let me know. We can set up a time during advisory. We got advisory on Thursdays and Fridays, and I'd be glad to help you out. I'd also be able to, you know, this 30-minute support time, that'd be a great time. In fact, if you want, during the support time, say, hey, Mr. Allen, can you help me get started on the homework for this week? I really struggle with it. Can you at least help me get a couple problems? I will be glad to do that, okay? So please, don't think there's no way you can make it through this class, because the answer is you can make it through this class. I promise you can, but you've got to be able to say, hey, Mr. Allen, let's set up some time, okay? And I'll be glad to help you. Any comments or questions on my little reminders? Okay, so let's go ahead and get to the content of this lesson. All right, so our objective today is to find and use relationships in similar right triangles. Now, guys, I'm just going to forewarn you. I think that this is the hardest section in this chapter. I think it's the hardest one for you to see what to do and what proportions to write. So I would highly encourage you to make sure. Thank you. Let's see here. Let's have you sit. Sorry, I go to my seat and try. Why don't you sit right there? Perfect time. Let's get started. Okay, sorry, kind of a little disruption there. Okay, so again, what I'm telling you is make sure you pay attention today. If you know, up to this point, and you might say, Mr. Ron, I feel like all the lessons you do are difficult. I hope that's not the case. But I'm telling you, this one's going to be kind of a tough one, so please pay careful attention. The other thing that I would recommend that you do during today's lesson is have your calculator handy. I'm going to have mine handy because there's going to be some stuff today that you're definitely going to want to use a calculator for. All right, so let's go ahead and look at section 6.4. 7.4. No, 6.4. Okay, 6.4. Here we go. It says altitude of a right triangle. I think it's 7.4. Am I on 7.4? 7.4. I teach 3 different classes, guys. It is hard to keep straight what I'm doing. First of all, this thing right here, this segment is called an altitude. If you think about the, like, I don't know if you probably have never been like mountain climbing, but they'll talk about the altitude of how high you are on the mountain. It's a vertical distance, and what it is it's a segment, and I've got the definition right here. It is a segment that's drawn from a vertex of a triangle, and it is perpendicular to the opposite side. Now, we've actually talked about these altitudes before. The interesting thing is in the case of a right triangle, there's actually only one altitude. Because if you draw the altitude from L, well, that's this side over here. This would be the altitude, so that's not really an altitude. It's already the side. Similarly, if you try to draw the altitude from J, well, it's got to be this side over here. So it turns out that the only altitude that we're dealing with when we talk about the altitude of a right triangle, the altitude of a right triangle, it's just this one right here. Oh, important question. How many triangles do you see in the picture? Come on. There are 3. That's exactly right. There are 3 triangles in this right triangle. I'll show them to you. First of all, I'll do them in different colors. There's the big one. It's in purple. Here's a small one right here. This one's in blue. That's triangle number 2. And then here is the green one, and that's the medium-sized one. So there are 3 triangles. And that's important to know. In fact, I'm just going to tell you that the whole key to everything we do today, it turns out that all 3 of those triangles are similar. All 3 of them are similar. I'm telling you that the blue triangle is similar to the green triangle, is similar to the purple triangle. If you can keep that in your mind with all these problems, it's actually not too hard of a section. But it's hard for students to comprehend that for some reason. Theorem 7.3. The altitude of the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangles and to each other. And this is exactly what I just said. If triangle ABC is a right triangle and it has an altitude drawn to the hypotenuse, that's what this thing is right here, that's an altitude, then all three pairs of triangles are similar. In other words, triangle ABC, that's the big one, is similar to triangle ACD. This is the small one. Similarly, no pun intended, the big triangle is similar to the, I'll call this one the medium one. And finally, the small one is similar to the medium one. So all three of those triangles are similar. So let's look at example 1. This is probably the most important example of all the ones that I do. It says, what similarity statement can be written relating the three triangles in this diagram? So here's what I would recommend that you do. Draw all three triangles separately. Let's do that. Let's draw all three triangles separately. So I'm going to start with, if you don't mind, I'm going to start with the big one. This is the big one right here. This is ACB, and you'll notice that that is the right angle right there. There's the big one. I'll call it the big one. That's the original triangle, ABC. Now, the next one I'm going to do is I'm going to do the middle one. Let's do it in blue. So I'm going to make it a little bit smaller. Okay, and we're talking about this guy over here. Now, do you see where the right angle is? The right angle is right here at D, so that's going to be D. Now, B is right here, and C is right there. And by the way, this is the middle one. Middle or medium, however you want to call it. And then green, let's do that one as the small one. Okay, so I'm going to make it the smallest looking triangle here. Again, my picture here isn't the greatest, but that's okay. Let's try to figure out where the right angle is. The right angle would be right here. So again, that's going to be D. This is going to be A, and this is going to be C. This is the small one. I have all three of them drawn separately, and what I've tried to do is I've tried to line up all of their congruent angles. So angle A is going to be congruent to angle C, which is also congruent to that angle A. Well, it kind of makes sense that angle A is congruent to angle A. It turns out, though, that this angle here, this is the angle C we're talking about in this problem. So here's the answer. The answer is triangle ABC. Triangle ABC. What's it similar to? Well, it's similar to triangle CBD. So I went A, B, C in that order. So I'm going to do the same thing here. C, B, D in that order. And can you guess what I'm going to do in the last one? Same order, right? I'm going to go bottom left, bottom right to the top. So it's going to be ACD. By the way, I hope you can see why all three of those triangles have to be similar. They all have AA, right? They all have this angle is congruent to this angle, congruent to this angle is congruent to this angle, is congruent to this angle. So all three of them are similar by the AA similarity. Now, questions on that first example. This first example is very important. This is something I think students struggle with the fact that on homework it's online. And so a lot of times students want to just be able to like see the answer. And I'm telling you, for me, this is coming from a guy that has a master's degree in math. It's easier for me to see this answer when I draw the triangles separately like this. If you just try to do this in your head, maybe you can do it, but you might make a mistake. And I hate for you to make a silly mistake and then get something wrong. Okay? All right, I'm going to go ahead and move on to the next thing. All right, the next thing is probably something that none of you have ever heard of, and it's something called the geometric mean. Has anybody ever heard of the geometric mean? I don't think we ever have talked about this in math up to this point. It was not discussed in algebra. You can probably understand why it wasn't discussed in algebra. It's literally got the word geometric, which means kind of geometry. And this is the definition for the geometric mean. There's a few ways to write it. I really don't care what way you write it, but I'm going to first off start with this one right here. What is that? That is a proportion, isn't it? It is a proportion. And that's what we've been talking about for this entire chapter, proportion. A is to X is X is to B. And how do we solve a proportion? Well, we cross multiply, right? So we would take X times X equals A times B, right? Well, what is X times X? Well, that's X squared equals A. Okay, that looks kind of familiar. So you can see where that came from. By the way, how do you get rid of the square root or the square? I just said it. You square root it, right? Oh, that's where that formula comes from. I don't care which one you use, but here's the basic idea. If you were asked to find the geometric mean of two numbers, you just do the square root of their product. The square root of the product. Now this is different, and let me make a note of this so that there's no confusion. This is different than just a regular mean. Call it regular mean. The regular mean of two numbers would be A plus B divided by 2. You should be familiar with that because we did that all the way back in chapter 1. That is if I said, what's the mean? The mean is another word for average. A geometric mean is something different. So this over here, that's all the way back from chapter 1. This is something new. This is something that you've probably never heard of. So this is going to take a little bit of practice. By the way, hopefully you can understand now why you might need a calculator. Square roots a lot of times turn out to be decimals. So let's look at some examples, and these are not hard. We're just going to use that formula on the last slide, okay? It says find the geometric mean of the two numbers. Okay, fine. So to find the geometric mean of 3 and 12, that's just X equals the square root of 3 times 12. What is 3 times 12? Well, if I'm not mistaken, I think it's 36. You can check that with your calculator if you like. Does anybody know what the square root of 36 is? It is 6. Now again, if you didn't know that, you could use your calculator to check that. And that's your answer. The geometric mean of 3 and 12 is 6. Now I want you to look at those two numbers. Would you have guessed it to be 6? I'll be honest, I don't think I would have. Now, since I already know the definition of geometric mean right here, I could calculate it in my head, but I don't know that I would have thought that the geometric mean of 3 and 12 would be 6. All right, would you go ahead and just do the next one on your own? You're going to do the exact same formula. All right, so on part B, you're just going to say X is going to be the square root of 4 times 12. Well, that means it's going to be the square root of, well, I think that's going to be 48. Now, here's a problem. What's the square root of 48? Yeah, it's a decimal. So I'm going to show you two answers here, so please make sure you add this to your notes. The first thing I'm going to write is this, and this is probably going to throw some of you for a loop. Just write that down, please, and just put a little box on. That's the answer. That's the correct answer. And then if you got your calculator, if you would just do the square root of 48, I'm going to write a squiggly equal sign, 6.9282 approximately. It goes on. It's an irrational number, but this is the approximate answer. This up here is exact, and it is what we call the simplified radical. Now, guys, we're going back down, kind of reviewing algebra 1 now. Let me explain where that came from. Hope you guys may not know this, but 48, did you know that 48 is the same thing as 16 times 3? If you're not sure, just check on your calculator. Take 16 times 3, you'll get 48. What's the square root of 16? It's 4. What's the square root of 3? Well, it doesn't have a square root because it's not a perfect square. In fact, let me review some of those perfect squares with you. Perfect squares. Perfect squares are like 1, 4. You know what the next one is? 9. You know what the next one is? 16. Next one. I'll give you a hint. 16 was 4 squared. What's the next one going to be? 25. Next one. Next one. 49. 64. 81. 100. 121, 144, 160. Anyways, you get the idea. Those perfect squares, when you do the square roots of those, you get nice numbers. Like the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So these are some common perfect squares. I don't know that you need to know that last column. In this class, I'm always going to let you use a calculator. You can check any of these. I mean, this is 169 here, sorry. So this number here happened to be the largest perfect square factor. So you may not remember this, but back when you were in Algebra 1, your teacher would have had you simplify radicals. They would have said, simplify the square root of 48. And then you would kind of be like, oh yeah, 16 goes into 48 3 times. And the square root of 16 is 4, so forth. Anyways, hopefully you remember that. If not, we'll probably need to review it some. Comments or questions on these two examples? Would you guys agree this isn't really that hard? This isn't really that hard. In fact, the hardest part of what I just did, probably for most of you, was this whole simplifying the radical part. I mean, if you got a calculator, you could come up with that answer pretty easy. All right. Oh, let me say one more thing before I move on. If the directions say, what's the geometric mean of the two numbers, and you give me the 6.928, is that answer okay? It is. Is this answer okay? 4 radical 3. It is. But if the directions say, find the geometric mean of the two numbers and leave it in simplified radical form, then you have to leave it as the box way. Does that make sense? If they don't say, or if I don't say, then either answer is fine. Okay, let's move on. Okay, so here's where things get a little bit dodgy. Remember I said in this right triangle with its altitude drawn, it has 3 similar triangles, right? The big one, the medium one, and then the small one. This is very important theorem, and I'm just going to read it to you and then I'll explain it. It says the length of the altitude, that's this distance right here, this length right here, the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. What in the world does that mean? In other words, we're talking about this and we're talking about this. So here's what I'm trying to say. If I'm trying to figure out what this is, let's say I let CD be x. And let's say I know that this is 3 and this is 12. What I'm telling you is this, and there's a couple ways you could write it. You could say 3 is to x, as x is, in fact, that's how I would write it. In fact, look over here. Look at this. What's AD? 3. What's CD? That's x. What's CD again? Well, that's x again. And what's DB? Well, that's exactly what I wrote. And now we're going to cross multiply. You're going to get x squared equals 36. So guess what x is? It's 6. The other way you could do this is you could just come right back here and say, hey, Mr. Elm, when we did this geometric means, we just use this formula right here. That's fine too. You could literally just say that x is the square root of 3 times 12. So the answer is the square root of 36, which is 6. Either way is completely acceptable. I typically will write it this way, but I really don't care how you write it. Yes? I just added them on there. Yeah, I just added these on here I was trying to connect it back to this last example. Yeah. And down here, look at this example. What's the length of the altitude? It's 4. So we could say 2 is to 4 as 4 is to 8. In other words, well, that's 16 equals 16. Check. In other words, 4 is equal to the square root of 2 times 8. Check. Okay, so let's look at an example. By the way, you could probably do this example right now. I'm going to do the exact same thing I did in the last 2 problems. You see that x there, that length x? Then this red segment right here, this red segment is called the altitude of a right triangle. This guy right here, that x, is the geometric mean of this piece and this piece. Go ahead and find the answer. You can do it. Okay, so let's look at this one. Now, I'm going to show you 2 different ways to do this, guys. I'm not doing that to be confusing. I'm doing that just to make sure everyone's aware that there's more than one way to do this. Here's how I would do the problem, but it doesn't mean what I do is better than the way you did it. I would say 84 is to x, as x is to 16. Let me explain why I would do that, okay? I want you to just consider these 2 smaller triangles here. And what I'm talking about, this one here is like the medium one. This one over here is the small one, right? If I draw both triangles like this, I'm going to draw the medium one here. Here's the small one. I'm not drawing the big triangle. I'm drawing the medium one and the small one. The medium one, well, what's its shorter leg? Well, it's x, right? What is its hypotenuse? What is its hypotenuse? Oops, let me see, that's not right. This is the leg, isn't it? This would be 84. Stay with me there. Does that make sense? So you see this, we're talking about this triangle right here. This triangle right here. The leg over here is x. This leg right here, because this is the right angle, is 84. Now, I'm going to erase all of that stuff. Get rid of all of that. Now, let's look at the small triangle over here on the right. You see the small triangle? What's its short leg's length? Well, it's 16. What's its other leg's length? It's x. So look at my proportion. Does that make sense? I'm going all the way back to that first idea that I put on this presentation. So now I'm going to go ahead and solve this. So I'm going to take x times x, that's x squared, and then I'm going to do the square root. Oops, sorry, not yet. Getting ahead of myself. Can't do the square root yet. And then I've got to take 84 times 16. Now, I do not know what 84 times 16 is, so I'm going to use my calculator, and I'm going to do 84 times 16, and I get 1,344. Now I'm going to do the square root of both sides. So I'm going to use my calculator again to do the square root of that answer, and I get that x is approximately 36.66. That's the answer that I got. Did you get the answer? Okay, good. Now, guys, I'm just going to let you know that the simplified radical form of this is 8 square root 21. Either answer is correct. The one in blue or turquoise, I guess, is probably a better answer because it's going to give more information to the person looking at that number. But I will take either. This question didn't say, put it in simplified radical form. So this decimal here would be fine. Okay. Now let me show you another way that you may have done this problem. Another way you may have done this problem is you might have just said, well, this altitude, x, is the geometric mean of these two numbers. Which might be an easier way for you to think about it. And you're right. You still get the same answer of 36.66. Any comments or questions on that example? Okay, I have a question for my virtual students. It is in a poll right now. You could please, this is kind of how I make sure you guys are paying attention, particularly through a virtual. All my students here in person are attentively paying attention, which I appreciate. Thank you. But if you are a virtual student, if you could complete that poll right now, I would appreciate it. There's a poll in the Google Meet. Alec, does that make sense? Yes. Okay. Tomas? Make sense? Does it seem as hard as I said it was, or is this not too bad? Not too. Okay, good. Okay. Sometimes it's stuff I think that people are going to think is hard. Okay, all right. Again, for those of you that are virtual, I just sent out a poll. I would appreciate it if you would complete that poll. All right, I'm going to look at the next theorem. By the way, this is the last theorem for the day. This is corollary 2 to theorem 7.3. Guys, this is, by the way, corollary is just a fancy word for like mini theorem. So here we go. We're going to use the same thing that I did, on this previous problem. This was the big idea, really, is that you have two similar triangles, and we're basically just setting up a proportion. This whole geometric mean thing, that's just kind of a shortcut. This one's a little bit different. Now, I'm going to read it to you, and I'll explain it as I read it. Make sure I'm in the bed. It says the altitude to the hypotenuse of a right triangle separates the hypotenuse, so the length of each leg of the triangle is the geometric mean of the lengths of the hypotenuse and the lengths of the segment of the hypotenuse adjacent to the leg. Good Lord. When you read that, you're kind of like, what? What did they just say? Let me show you what what that means. Here's what it, no pun intended. Let's say that this leg right here, or this side right here is X. You see AC? Let's say that's X. It's telling you that X is the geometric mean of AD and AB. Let me write that down. X is going to be equal to the geometric mean of AD's length times BD. Now you might say, wait a minute, Stroud, they did not write they didn't write it that way over here. I know. Oh, I wrote that wrong. Sorry guys, let me fix that. It should be AD to AB. This says that each leg's length of that triangle is the geometric mean of the hypotenuse. This is the hypotenuse, and the segment of the hypotenuse adjacent to that leg. So X is the geometric mean of the hypotenuse, that's AB, and then AD. Similarly, but I'll do it in a different color. I'm going to do this in purple. This leg over here, we'll call it Y. This leg over here, we'll call it Y. It is going to be equal to AB times DB. Let me erase what I have here. AB, that's the length of the hypotenuse. It's the geometric mean of the length of the hypotenuse, and then the segment of the hypotenuse that's adjacent to that leg. You guys agree that one may be a little trickier? So look down at this example here. I'm telling you that 2 is the geometric mean of 1 and 4. That's what I'm saying. And I think that you could just think about that mathematically, and that makes sense. In other words, 1 is to 2 as 2 is to 4. Again, if we draw these triangles separately, you'll see that that will be proportional. Let's do an example, okay? We are trying to figure out what this length is right there. We'll call it Y. That leg, I'll just do this. I'm going to do this one the kind of the easier way. Y is the geometric mean of what? Well, this length and then this whole length. In other words, it's 35 times 7. That is what the length of Y is. It is the geometric mean of the length of the hypotenuse and then the segment of the hypotenuse that's closest to Y. Would you guys go and use your calculators now to figure out what that is? Go ahead and round it to 2 decimal places. Good. By the way, good job, virtual students. The answers that you got there for the poll question is right. Good. Alec, what did you get for an answer there, buddy? $245. Yes, square. It's the square root of 245. What's the square root of 245 though? You got it. That's exactly right. So there's your answer for this problem. If that little piece right here is 7, and this whole length here is 35, then Y is 15.65 approximately. By the way, the exact answer would be 7 radical 5. This is the exact answer here. This is exact, and this one over here is approximate. You guys understand what the squiggly equals means, that it's not exactly the right answer. It means it's round. Okay. Comments or questions on that one? By the way, if you understood that example, we're pretty much done. There's really nothing else that I'm going to tell you guys today. We're doing great on time too. We're going to right what we need. All right, so I'm going to do this one. Actually, you know what? I'm going to let you guys try this one. Just give it a shot. What is X and what is Y? I'd like you to figure out what X is and what Y is. And you're going to have to use the two previous theorems that we just talked about, the two corollaries. Figure out what X and Y is. Feel free to use your calculator. I'm going to finish checking attendance here real quick. Okay, let's go ahead and look at this one. I'm going to start with X, but if you started with Y, that's fine. So X is going to be the geometric mean of 4 and 9. Because if this distance is 4, then the whole distance of the hypotenuse would be 4 plus 5, which is 9. So X is going to be the geometric mean of 4 and 9. So that's going to be the square root of 36. So that's going to be 6. X is equal to 6. That was what we just did, the last example. Okay, so let me say that again. X is the geometric mean of the whole length of this hypotenuse, and then just that part of the hypotenuse there closest to X. I'll put a little note. This is like example number 4. Let's go ahead and figure out what Y is. I'm just going to tell you right now, Y is going to be like example 3. So to find Y, that's this length right here. That's what Y is. Y is going to be the geometric mean of 4 times 5. So it's the square root of 20, which is 2 radical 5, which is 4.47. Either one of those answers is good. Now again, I think that these types of problems are difficult for students to get. I think that it's hard for them to kind of separate stuff, but maybe you guys are seeing this a little bit more clearly than I am. We've got one more example. We're done. We're going to come right to our 1 hour mark, which is good. And I have one more question for my virtual students. You've been taking notes. It should be no problem. Okay. So let's go. Comments or questions on this one? Good? All right. Last one. Last example for the day. And it's an application. It says roof height. A roof has a cross-section that is a right angle. The diagram shows the approximate dimensions of this cross-section. Identify the similar triangles. Find the height h of the roof. So let's see here. They give us all kinds of stuff. They tell us that this length here is 5.5. They tell us that this length here is 3.1. And they tell us that this length right here is 6.3. So the first question is to identify the similar triangles. So here's what I'm going to ask you to do right now, and I'm going to let you try this one. I'm telling you that there are 3 similar triangles. Can you write them? and in the correct order. And you have to use these letters, Z, W, X, and Y. Can you do that? Take a minute right now, try to write those in the correct order. Okay, so I'm going to follow my own advice that I gave you earlier on in this presentation, and I said what works for me is to just draw them separately, but you can do whatever you want. Let's see if you got the right answer. Now, guys, remember, it depends on the order in which you set these up, okay? For this big triangle, how do you guys want me to call this big purple triangle? You want me to call it X, Y, Z? Is that okay? I'm going to call this first triangle X, Y, Z. This first triangle, this is the big one. I'm going to call it X, Y, Z, okay? If that's the first triangle, what's this one here in the middle going to have to be? Y, W, Z. And what's the last one going to have to be? X, W, Y. This is the correct answer for the first one. Now be careful. Don't be too quick to say you didn't get it right. What is important here is that all of these letters are in the same order with regard to their congruent triangles that are corresponding. So for example, it is important that this angle and this angle and this angle in all three of those triangles are basically the same. So look, you see how Z here, and then Y? So it had to be Z here, and then Y. The order of the letters is important. Similarly, you see here that I had Y next. Y in the first triangle is right there. In fact, let me do 2 marks. If Y is the second one, then W has to be the second one here. And W is going to be the second one in this last one. And you'll notice that that is indeed the case. You'll notice that the second, or the 2 underlines are under the second letter each time. And then, of course, the last one is the last one. So that's easy. Okay. Last thing but not least. Did anybody find the length of the height H? Well, let me show you how to do that one, and then we'll be done. I'm going to mark it in black. So look, by the way, remember, purple is our big triangle. We know that this is 5.5. We know that this is 6.3. And we know that this is 3.1. Now, look at that middle triangle. What are the only 2 sides that we know in the middle triangle? In fact, we only really know one side. You see the middle triangle, which is this guy right here? What is the only side we know in that triangle? Because we don't know just this distance, do we? This whole distance here is 6.3. It's just from Z to W, though, that's this side. We only know the hypotenuse of the middle one is 5.5. By the way, the hypotenuse is ZY, so ZY has to be 5.5. What about the last triangle? What's the only thing we know there? Oh, I guess I could add one more thing. I could say that this was H, right? In that median triangle. That's got to be H. What about the small triangle? Well, we know XY. What's XY? 3.1. I can put 3.1 there. What's WY? WY is H, and I don't know what that other side is. Now, guys, I'm going to erase all this stuff I have up here because this is getting to be kind of a hot mess and I don't want to be too confused. Now my question is, how can I find H? There's more than one way, I think. Maybe there's only. Can anyone tell me a proportion I can write? By the way, all three of those triangles are similar. Can I write a proportion that will tell me what H is? Well, here's the ones I'm going to use. I'm going to use these two guys right here. I'm going to say 3.1 is to H as 6.3 is to 5.5. So let's write that down. But here's my second answer. Here's for B. I'm going to say 6.3 is to 5.5 as 3.1 is to H. And by the way, you could write it the way I said first. I mean, it's the same thing, right? I could have written 3.1 is to H and 6.3 is to 5. Same thing, right? Would you go ahead and find H for me? I've done the heavy lifting. Can you find H? I think you might have a decimal there. Yeah, right on 2. I think it's 2.70. 6. We'll go a little bit crazy there. So I'm just going to say it's about 2.7 meters. That's your final answer. Now, guys, as I finish up today here, and we're going to move into our last piece here. Guys, if you're here in class, I've got an exit slip that I'd like you guys to fill out too. If you could log in very quickly to the Google Meet and fill this out before you leave, I'd like to get your guys' feedback. Before we wrap up, though, and I'll put it in the chat. For those of you guys that are virtual, here it is. Hopefully that's the right form. Guys, what are we talking about today? Still, similar triangles. Every problem I did today basically involved this triangle being similar to that triangle, which involved a proportion. All of them, even the ones where we did this square root stuff. Even these here, for example, this one here, I could have done x, 4 is to x as x is to 9. And it will still give me 6. You can check that. There's still 3 similar triangles. We're still dealing with similar triangles. Okay, so that's it for today. Don't forget, tomorrow you have a quiz. You have homework tomorrow night due at 9. I'm going to shut up now, and I'm going to leave it up to you. If you have questions, stay on, ask me questions, put them in the chat, unmute yourself. I'll be glad to help you with whatever you need help with, whether that be understanding what I did today. Maybe you need to see some more examples. Maybe you want some help on the practice quiz I gave you. Whatever it is, let me know. I'll be glad to help you guys out. Okay, those of you that just joined the Google Meet, I just added the form there. Just in case you didn't get the Christmas. Ooh, he does not. That's interesting. Be careful on these questions, guys. They're not really hard, but don't guess.